Very good morning to you, and thank you very much for joining our Flotation Energy webinar this morning. My name is Jaya Calder from Highlands and Islands Enterprise, and I'm going to be helping to run the webinar this morning. Now, before I pass over to my colleague George, if this is the first time you've joined one of our webinars using GoTo, my role is to connect you, the audience, with our speakers. You're automatically muted and we can't see you, but we actively encourage your engagement. So there's a couple of ways we're going to do that. You'll see a chat question box. If you've got any questions, observations, or just any dialogue you want to share with myself as running the webinar or with our speakers, pop it in the chat and then I'll share that with our speakers. And when we come to a formal Q&A at the end, pop your questions in and I can also share those. The other way that when we come to a Q&A is if you have a microphone, then we're happy if you'll see a wee icon, a raised hand. If you click on that, then I can take you off mute and link you again with the speakers. And the last thing I need to do to advise everyone before I pass over to George Irvine is we're recording today's session. Where we can, we will share the presentation and also share the recording link with you so you can share that with your colleagues. So we've got a lot to get through this morning. So I'd like to invite George from High to turn his camera on and to do the intros. Thank you.
Good morning, everybody. Welcome to the webinar. I'll keep this fairly brief because we do have quite a lot to get through. We're going to have speakers from Flotation Energy. We've got Alan McCaskill, a director at Flotation Energy. We've also got Paul Both. He's the engineering manager, and I'm very much looking forward to this webinar because these guys have been there and done it. They were instrumental in the design, commissioning, and the operation of the Kincardine offshore wind project. And they've both worked in oil and gas and transitioned over to renewables because it's something they really believe in. We also have Kirstine Wood, who will be, she's the communications manager at Flotation Energy. She'll be joining us at the end for our question and answer session. So without further ado, I think I'm just going to pass over to Alan, and he's going to give a company overview before passing to Paul. Okay, if you can turn your camera on.
Okay.
And there we go, there's Alan. And
okay.
I'll go and hide.
Okay, yeah, my name's Alan McCaskill. I am one of the founder directors of Flotation Energy, and together with our partner Cobra, we bid for a number of sites in Scotland, and we're very interested in site NE1 east of Shetland, where we believe that there is a significant opportunity in clearing. So I would like to move on to the next slide. Is Kirsten? Oh yeah, okay. So who are we and what are we? Well, what you see here is a series of projects round about the North Sea, but basically we're a dedicated renewable energy company with a track record which goes back through the staff in this company all the way to the first jackets put into the North Sea for offshore wind in 2005 at Beatrice. And so through the demonstrator all the way to the energy transition, we're involved. Our partnership with Cobra is looking at Whitehorse, sorry, my apologies, Whitecross, which is a floating test and demonstration site in the Celtic Sea, the Morecambe site in the Irish Sea, and we'll be very interested in the NE1 site in the off Shetland. Equally, we're also involved with Senos and Greenvolt, which are part of the INTOG process that is running also this year, and we aim to try and win those sites during that. We're headquartered in Edinburgh. We have a significant number of our staff based in Aberdeen, and so we are a Scottish company, and our partner is Cobra, and Cobra is based in Madrid. Can we move to the next slide, please? So you see NE1 here, and What we would like to do is to deliver this site in partnership with Cobra Instalaciones y Servicios, which are our partner with whom we are working and delivering on basically the fields in, I mentioned Morecambe and Whitecross, and also with whom we're trying to develop some opportunities in Ireland, one fixed in the Irish Sea and one floating in the Celtic Sea. And basically what we're to talk to you about today is how we'll bring all of this together to drive forward a development of NE1 using our Offshore Wind Limited partnership. Can we try the next slide, please? So what we're, basically we believe, and we've been up visiting Shetland a few times. We know that there's a lot of aspiration to be a green energy centre on Shetland, and we basically think that that is something which we would like to be part of. We see that the opportunity for NE1 is to tie it in to the production of hydrogen, and to use that as part of the energy transition, exporting the power possibly as electricity, but more likely as hydrogen or other alternative fuels to the mainland or internationally for use. We also understand the challenges in Shetland in terms of fuel poverty and various issues like that. And we think that there may be some things that can be done in conjunction with this project to address that. We basically have a unique value proposition, in the sense that, we have been involved in this industry, the wind industry, and been pioneers of it since I started, along with some other members of our team, way back in 2003, when we got the process going to build the Beatrice demonstrator project, which was at its time the furthest, the deepest, and the largest machines installed in the offshore wind industry, and also the first to go on jackets. Part of our knowledge and we believe our expertise is the fact that quite a number of us are not just wind professionals, but also oil and gas professionals with a track record of delivering electrification and integrating it with wind power. That's only been done once, as far as I'm aware. Actually, that's not true. It's been done twice. It's been done in China, in the Bohai Bay, where a 2-megawatt wind farm was integrated into an offshore wind farm there in the Yellow Sea. But the only place it's been completely properly done is here in the UK, in Scotland, in the Beatrice field. When I was with Talisman in '99, we electrified Beatrice, powered it purely from the grid, and then early noughties, we then added on the turbines to provide us with all the electricity we need. But from late 90s, Beatrice ran purely on electricity from shore with no offshore power generation. We've got a lot of relationships within the industry. We know who to talk to. We've been working, as I say, on a number of different projects. And what we're aiming for is trying to get to a world where oil and gas can be rapidly and decarbonized by the removal of the production process electric generation, switching that to renewable energy. We see a huge opportunity here within both the NE1 and also the INTOG process to actually accelerate the potential decarbonization of a number of the oil fields of the northern North Sea. And we've got discussions running with a number of companies. And what we're interested in seeing there is where you might be able to do a pilot program where you would actually be able to develop part or accelerate the development of part of NE1, but use it to power some of the oil fields initially by locating it near the oil fields and then bringing it back to the NE1 site at a later date once the work has been completed and those oil fields have been decommissioned. So that's one of the key things that we're looking for and trying to work on at this stage. It's something that's in its infancy, but we've had a number of discussions and we're working our way towards it. So can we move to the next slide, please? So what do we bring to oil and gas decarbonisation? Well, we recognise that, you know, we need to keep the oil and gas business running as long as we can while we continue the transformation towards a renewable future. And electrification is key to reduce the emissions associated with oil and gas decarbonisation. We understand how to do that, and we understand the challenges associated with it, simply because we're one of the few people within our team, a number of us were responsible for delivering that. First, by actually switching Beatrice from an offshore power generated field that was augmented by oil and by grid power to pure grid power, and then by bringing in the 2 turbines, integrating them into the field, and using that along with the grid to continue to power that plant. The impact of that was a field which is due to be shut down in 1999 did not finally decommission until 2015. And that was the key sorts of issues that we've got doing that. So we believe you can extend the decommissioning, cessation of production, if you want, timelines. You can make it commercially attractive to decarbonize the oil fields by minimizing the brownfield mods and at the same time finding a reuse option for the turbines. And that's what NE1 has the potential to achieve. Allowing the depletion of the costs of the turbines over the overall life of the field of the wind farm rather than over the remaining life of the oil field. So that's the opportunity that we perceive. And all of that can be integrated into a development at NE1 where you then choose to send the bulk of the power into Shetland and then basically probably towards Sullom Voe, where you would convert it into hydrogen and sell the hydrogen into the global markets. That I think is a much better solution in the area in Shetland than trying to put another cable all the way to the Scottish mainland. Next slide, please. I think this is where I start to hand over to you, isn't it, Paul, on the detail of how we would go about it and where we might look at it, and then the facilities and opportunities that we require.
Just invite Paul to turn his camera on and come off mute. Thanks.
Right, that's me. Hopefully everybody can hear me. So as Alan said, yeah, this is where I sort of take over. The idea of this section is to look at what Shetland can offer, the transition that Alan's been talking about, and the NE1 site in specific. And we'll go through this in some detail over about probably 10 slides or so. And I'm not going to read this one out because everybody's going to get a copy of this, but really we have some knowledge of Shetland. I personally worked up there for 2 years. I was at Sullom Voe with a company called AMEC. I became Civils Technical Authority for a brief period. I lived in St Sunniva Street, and I can tell you a story about how germ warfare came to Lerwick following 9/11, when the power went off in the freezer and I was away for 3 weeks. That was lovely. So my background, as Alan says, we're oil and gas and renewables. I've got about 30 years in oil and gas in heavy construction, and the last 10 years in renewables, some of which has been on Kincardine, which is a project we're going to use as the basis of this discussion, and now moved across, following Alan essentially, into flotation energy, and on now to the NE1 project and the decarbonisation project. So can we go to the next slide, please? Okay, so Kincardine was completed 2019, 2020. It's 5 turbines, each 10 megawatt or 9.5 megawatts, about 50 megawatts of installed power. We learned a lot of lessons from it, and really the main ones are here. So substructures need to be stable in shallower depths. These turbines require about 13 meters alongside. That's suitable in Shetland, but in general for the wider market, you really want that about 8 meters chart datum. To get the production rate that we require, this is where projects come into more a production line than an oil and gas prototype. The idea really is the structure is broken down, it's built in parts. They can be built over a wide area to maximize the use of yards, and then brought as large components to an integration site. And what we'll look at in this presentation is integrating at Dalesville. You also then want to keep the tow as short as possible. Once you've got the substructure in the water, you've got the turbine on it, you really want to be, as it says here, about 48 hours from departure to securing on site and getting the cables on so you can start generating. So we want everything to be as compact as we can get it, and the NE1 site is straight line distance, about 30 kilometers from Lerwick. The tow distance will be a bit longer, but it's nice and close. It's good. So next slide, please. So what I've done with these slides is to try and break it down. This is Kincardine, one of the structures there. This is a structure for a 9.5 megawatt machine. It weighs just under 4,000 tons. It was built in parts, but it was all built in one yard and then towed up, which is not what we want to do in future. In the middle of the slide, you'll see there's a table. This is to guide everybody in the call as to what we will be looking for from the supply chain, and give you an idea of that so that you can come back to us and see, we can work together on what the actual offerings will be. So cranes, 500 tons, that's about the heaviest one of these tanks. They look like legs, but we tend to refer to them as tanks. For a 4,000 ton structure, we're going to load out, we're going to need SPMTs. There's quite a lot of engineering work to be done, and this is out with the design. This is for the build. For stillages, you can see they're obviously going to be built high up so we can get SPMTs underneath them. Each substructure will take about 1 hectare to build in. They're roughly 100 meters on a side, maybe slightly larger, triangular, but you still need access for cranes, etc. around them. So 1 hectare per unit is what we're looking at. And they're obviously heavy, so where we've got big things resting, we reckon around 50 tons a square meter, and a key edge capacity of about 500 tons per meter just on load out. This is assuming that we're going to load out onto a barge. Okay. And you see the other bits of trade there. So the left-hand side is what a module would look like, and on the right-hand side there, you've got what the modules look like coming together to form a complete structure. Next slide, please. These are some of the Kincardine structures. These are the ones that are there now. They are loaded onto this barge. It looks like a ship, but actually it's not powered. It has to be towed. It is a barge and it's semi-submersible. So the way this was done was the structures were loaded out onto the barge. You can see the triangular stools on the deck, triangular formation. they're towed on this and then lowered into the water, readiness for the turbine to be put on. So, for example, doing this around Dalesville, you could use a barge similar to this, load out, lower into the water, tow them to potentially a semi-submersible crane or a jack-up where the turbine will be put on. But we'll come to that on the next slide, please. Integration of the substructure. Now, I've used two photographs on the left here. This is the first small turbine that went to Kincardine. It was a 2 megawatt machine, and this is done in Dundee. You can lift the turbines from the quayside. However, at the size of turbine we will be looking at for NE1 and our other projects, that nacelle, the bit where the blades will go on eventually, weighs about 800 tons. Their turbines are much bigger than they used to be, and they're growing fast. So we can use onshore cranes, subject to the load capacity in the quayside, to take the weight of the crane and the lifted load. Or on the right side there, you see a turbine being installed by a floating crane. There's nothing to stop that being a jack-up. So that's a couple of alternatives. You can either do it at the quay or you can do it in the water. Either which way, it needs to be done inshore, and the VOs are really well protected for doing this kind of lift. Next slide, please. So we've talked about Dalesville. Coming back to Lerwick itself, lots of anchor handling will be required. Each of these substructures will require 3 or 4 anchors, depending on the amount of redundancy that are required to keep them stable. Each anchor leg is going to be about 1 kilometre of chain. If we put in 30 turbines, you would be looking then at 30 to 40 kilometres of chain, times 3, so 90 to 100 kilometres of chain. It's going to be 4-inch probably, with big anchors. So the thought there is we probably wouldn't want to keep everything in one site. We want to spread this about, so potentially at Greenhead. Next slide, please. Cable installation, slightly different approach here. Cables are made around Europe and in the Far East, and the way they're picked up as a ship goes in, it's all fitted out like this. It picks up the cable at the manufacturer and it goes straight to site. And the reason behind that is that you want to minimize the handling of the cable as much as possible. You don't want to load it in to a carousel, bring it up somewhere, unload it, reload it, and put it in the water. Every time you move it, you're going to get potential damage. For the installation process, there's a lot of work actually comes on the turbines when the cables come on. We need fitters to build what's called a cable management system, which is the frame that the cables are carried on inside the turbine. We do that offshore if need be, because these cables are very stiff and sometimes you just need a bit more room. We need electricians to do the terminations, and we need riggers because these things are quite heavy. And there will always be things like repair of coatings, etc., because things get damaged when you're pulling stuff in. So there's also a piece there on vessel chartering. We'll need to move some equipment around. That could be spares, cable joints, etc. When these vessels are operating, all the construction vessels, in fact, we'll need guard vessels in the site. We'll need barges, because one of the questions we've been asked is, what is the local market like potentially for chartering vessels? So that's just one piece there. Next, please. Similar photograph, but you'll see in the bottom right there, there's a rock in the place. That is for the export system. So these are the cables that come in from the turbines to shore. They're generally pulled from the shore out to the wind farm. So this is where we start to interface with the land. We need the vessel to come in very close. This is the Kincardine cables being brought. They were pulled up through drilled ducts in the quayside, in the cliffside, south of Aberdeen, and then they're laid out to the offshore substation, if that's what we do, or straight to the turbines. What this brings in is we start to bring in the need for a lot of civil engineering works, because we would need to build a jointing pit, which is basically a big underground tank in which the cables are joined from their offshore side to the onshore side. They're different specification of cables. There's quite a lot of demand for people to do this aspect as well, and particularly the next slide, please. So onshore export cable, we would look to tie in to a grid network as close as we can to the landfall. But what we've touched on briefly with Alan is that, let's say Sullom Voe was to move towards hydrogen, etc., or ammonia, we would also have to lay cables to go up there. I know there is a power cable comes down from Sullom, but we'd probably need more power than that cable would take. So this is an option here where we would lay the cables in the ground. So we need trenching, we need to build roads. These are haul roads specifically. You can see the sort of cartoon diagram on the right-hand side with 2 cable tracks. And the larger one is the main excavation. There's quite a lot of onshore as well. It's not an entirely offshore job. Next, please. So we talked a bit there about construction and actually getting the project going. The main part of an offshore wind farm is operations and maintenance. Construction you could expect to last about 2 years. Operations and maintenance would be 30, heading towards 60. The leases are 60 years. We'd probably look at doing something around 30, 35 years with the turbines. So if you like, the legacy of building a wind farm off Shetland is this piece. You have options for the type of vessel you use, crew transfer vessel, small, fast, not very good for transferring people in anything above about 1.5 meters significant onto the turbines. You can go for an SOV, much bigger, much slower, gyro-stabilized gangways, etc. Making life a good bit easier. CTVs tend to need pontoons in a port. SOVs can go up against the quayside. So these are the nominal parameters that we would need for an O&M base in terms of outside storage, warehousing, some climate control storage, etc. All within that. These bits would be in the warehouse. There's an office block where the operators actually work. In the office block, there is the control room for the wind farm. It acts as a node on the grid, if the wind farm's grid connected. It needs to be in a secure area because of that. So generally in the port, inside the port perimeter, and it will have internal security on it as well, and then well protected, good quality offices. Next slide, please. Okay, so what does it look like, an O&M base? Well, the 3 of the photographs, not including the big red SVAG vessel, these are taken in Montrose. They've just built an O&M base. On the left-hand side, you see the office there, as described. In the foreground, you see a lattice structure. That's a comms tower, which is there really to just lift the aerials so that people can speak direct to offshore. The layout is on the right, showing how the base sits in a port. In this case, it's right down at the east end of the port. There's a pontoon for crew transfer vessels. There's a warehouse there already, so that's been repurposed. But that shows the general layout of what you need. So photographs below, the SVAC vessel is an SOV. So you see the tower on the back of it, that's got a gyro stabilized gangway. That would tend to go out, stay out for 2 weeks, and transfer people on and off the turbines for general maintenance. So it's on a sort of very much like a supply boat type rotation. On the right, crew transfer vessel, fast, small, and good to act as a taxi. Now, to build one of these bases is very much a standard building project. We would be looking at standard steel erection for the building, foundations, civils, lots of general work around, as you would have with comms, cables, etc. What I haven't put in here, slightly remiss, is the onshore end of the cable at a substation. That is a fairly specialist piece. We would have that specifically designed. You would build a set of bases and roadways in it, and then there'd be probably an external contractor who would come along, something like ABB or GE, and they would put in all the transformers, filters, etc. There still would be quite a need for civils and general building work around that, and electrical hookups. We go to the next slide, please. I want to give you an idea of what we're looking at in jobs. Now, if we go for a 1 gigawatt, so 1,000 watt wind farm, the number of jobs by time, and these are local and regional. So for this, I would take Shetland and probably northern Scotland, down as far as Aberdeen. It's a relatively slow ramp up from sort of time now through getting the front end engineering done. The big milestone we're anticipating is around 2025 when we get our consents in place and then go to our financial investment decision. From there on, there's a couple of years of detailed design, and then we go into construction. And construction's a great big peak because there's going to be lots of things going on. There's vessel crews, there's onshore and offshore works all happening at the same time. And from the operational phase, we move into this O&M period, which is the lasting piece, and that would run out probably till, in that case, about 2060, with roughly 75 jobs arising from that. Now, there will be other jobs. The direct jobs are the people who actually work on the project, really hands-on. Indirect are the suppliers. So for steelwork, LEF, Malakoff, people like that would be able to contribute into those. Induced jobs are the jobs in services particularly. So hotel staff, shops, general people who are helping out. And then the total is obviously the sum of that. Now we can go a bit wider out on jobs just to give you an idea of what the project looks. And next slide, please. So what you see, these numbers don't include the numbers we've already seen. So to the wider UK economy, you can see here it's a very similar profile. Big thing during construction, ramping up, big construction, and then O&M. And the wider UK part is the direct jobs are people who will generally be, they're still in contact with the project. They might not necessarily be on Shetlands. And then we've got other jobs and suppliers, tertiary supply, going down the supply chain. So, when you're into this, you're into people, specialists from wind turbine manufacturers, grid personnel, etc. So this is the wider UK jobs, but the Shetland jobs are on the previous slide. They're probably most of interest to this discussion. And how these are worked out is a calculation done on project spend, and a methodology was put forward, and it's used by the planning inspectorate, that for every X amount of spend, you create a job. So I can go into this. Do you want to do this one, Alan? I can run through it. The next slide. No, we're happy to go to the next slide. Okay, I'll run down it. So this is our timeline. We will be bidding for the site later this year, probably late summer. And at the moment we are talking to supply chain port authorities. That's really what part of this call is about. We will be putting links on a website where people can register their interest. We will then go through that. We'll go through a pre-qualification process. We're going to have to spend a bit of time coming up, as in coming up to site, getting to know the lie of the land a bit more. And we will be, throughout this, talking directly to suppliers. And we will be up in Shetland as opposed to doing just webinars like this. And then there is integrated webinars, chats, meetings, site visits, etc., all the way through until we've actually got in properly into the procurement process. Procurement starts just around financial investment decision. Some of the big contracts would be out slightly before that, like turbine supply. And as we come towards construction, the smaller and smaller contracts are issued and agreed. So there is a lot of option here for Shetland suppliers to come in, talk to us, show what we can offer. I was told on Friday about the Norn Group, which I believe is Vore Energy, Malacloth, LEF, and maybe some others as well. We're interested in talking to anybody and all on this, so we understand our supply chain. And one of the big questions that we will have is, how do you feel about gearing up for all of this? It's a big project, or projects, because there are decarbonisation projects that could use exactly the same supply chain and that we are interested in as well. We're concentrating on NE1 just now, but there are others. So we're very interested for this to be a two-way street, not just one. So next slide. This is the last slide we've got. So this really are the 5 bullet points that we as Flotation Energy guide ourselves by. We're always looking at innovation. I started in renewables on cables. I did design installation work for Kincardine. I followed Kincardine through with Alan into Flotation Energy. and I'm engineering manager covering all the projects that Alan showed earlier on. We do adapt because we have no fixed decision on the type of substructure, etc. We will adapt to the market, and the supply chain is adapting really fast because of the size of the opportunities, not just in the UK, but also globally. Care for our environment. These are green projects. We want to make sure that they remain green and we supply as much green energy as we can. And we tend to want to work as collaboratively with the supply chain and the communities, all the environmental bodies. I don't really want to read this out, but you get the idea. And then primarily, we want to treat others as we would like to be treated. Respect, in other words. So I've just seen a question come up. I will answer this one just because.
I'll just come to the questions, Paul. I'll just get everyone, if that's you ready, I'll get all of our panelists to our cameras on and come off mute. If we can do that. I'll just check that, Alan, if you can come off mute.
Okay.
Alan, can you, that should be you now if you unmute.
Okay.
That's it. Okay.
Well, going to the questions, could I just make one thing clear, which I think is important? We talked about there was the ability to use export electricity and the ability to export hydrogen. These schedules that we talked about here assume we're going to export hydrogen, and we believe that hydrogen is the way out for anyone. But you know, there is always an alternative which could allow you, but it would be much delayed because electrical connections would not be available for a number of years. That's why we are interested in hydrogen.
Alan, thanks very much for making that point. And a welcome to Kirstin as well. First time our audience will have met Kirstin. What I'll do, panel, is I'll read the questions out to you, and if you can indicate that if it's not been already allocated for someone, you can let me know if you'd like to do that. And to our audience, if you can, there's oodles of time for questions, so please use your question box and put your questions in. But the first question is directed to Paul. In your slides on ports, you talk about Dalesville and Lerwick Port for assembly and O&M. Are you also considering other ports, such as Port of Sullom Voe, which is linked to SVT and Skatstad?
Yes, the reason I've started with Lerwick or Lerwick Port Authority area, including Dalesville, obviously, is that is an existing facility which is there and ready. There is nothing to stop us moving later to Sullom Voe. As I mentioned earlier, I was briefly Civils Technical Authority up there, so I actually know that area pretty well. Where that might sit slightly better is in the production of, say, hydrogen, where you've got the petrochemical knowledge up there, the handling of gases, etc. We could probably supply power up there, which would then could be used for the production of alternative fuels. We're not excluding it. At the moment, for the first project, we don't want to particularly build ports, so we would start on the ports that already exist. Because if you notice on the timelines here, they're not very long. They look like quite a long time, but they're not very long. If we're operational in 6 years, that's not a long time.
Thanks for your response. Next question. Is the intention to use floating structures of the same type as Kincardine project, i.e. the principal power, or is it undecided? And the presentation has focused on these as typical examples of what the floating structures will look like and the space they require.
I think it's fair to say that that's an area where we've got a lot of expertise, and we have been, because obviously we've got the Celtic Sea project, which we've been talking to most of the designers, shall we say, initially. And also we've got Greenvolt and Senos, and in each of those cases, we've also talked to the designers. We're trying to make sure we get designs which are suitable for use in the east coast of Scotland. And also, I think one of the key things is that those designs are modular, such that, you know, what we're aiming to do as close to site as possible is to actually put the machines together and to do two things. One is to assemble the substructures from these modules, and the other one is to potentially at a separate location, we have a sort of belief that that might be better, to then integrate the tower, the turbine, and the blades at that location. And that needs a lot of pre-work on things like the towers, where the towers come in parts and you have to assemble them, you have to put all the cables into them, such that, you know, once you pick the tower up and you put it on the machine and you then put the nacelle and the blades on, it's a very simple process and it can all be done within about 24 hours. But that's because there's been a lot of work done up front in the yard to make sure that those towers are ready to go on the machinery. And then how do we go about doing that? Well, we've got a number of ideas, which I think Paul sort of intimated, about whether we use jackups, whether we go to the quayside, but I'll maybe pass over at that point to Paul.
No, that's right. The lessons learned from Kincardine, which we started that on, are if you say put the tower together on the turbine, and it usually is in 3 sections, you've got to joint it. By the time you've got the turbine onto it, you're looking at somewhere over a week to get the whole piece. If you were to build the tower up completely ashore and the cells all there, you can get it down to much, much shorter, with a target time down to about 24 hours. Offshore, with jackups, we know that the bigger jackups anyway can probably get down to about that, but that does assume there's a lot of pre-work done in cabling up the tower sections. We are undecided on which substructures to use. We obviously have principal power, and I used them as an example, but they are equal to other designs. I think at the moment we've looked at 15 designs plus in some level. Our first filter is how close are they to being deployable? Because if something's a notion today, it's going to take a good few years before it can actually be demonstrated and ready for commercial use. We are interested in going straight to commercial. So principal power does feature, but that does not mean to say that principal power are it. There are plenty of others.
But one of the things I was going to say, principal power, as you say, are the leading designer at the moment, because they've got more equipment installed in the world than anybody else. However, the design needs to be changed, and they know that. And so they're also moving to the designs, and others are catching up behind them. So we are in discussion with probably 4 or 5 that we think are the right ones. And we will have to choose the final one in the future. And the other one, and I think it's why we are interested in the concept of having fundamentally an assembly site and an integration site, is this idea that, you know, you've got a lot of logistics to do, you've got a variety of different things to do to make the turbines ready for installation, such that you can install them very quickly on the machine and then get the machine to market. I think, and this is one which I think I saw a question earlier or somewhere about would we have lots of them hanging around waiting to go to site and be integrated? I don't think we'd think that's a very good idea. We'd rather have the machine assembled, move it to the integration site, and then integrate it and take it straight out to site where it's locked in and moored up, because that is where it's designed to be, rather than having a temporary place in and around the port, because they're big, they take up a lot of space, and it's just a lot of time and effort moving them. You want to move them as little as possible, and that's it. So that's one of the things we're looking at.
Thank you very much for that.
Sorry, just on from that, Alan. Do you see that being a summer campaign, or is this something that would continue through the winter months?
I think that the answer is that we tried to do Kincardine through the winter months, and it didn't work very well. We hung around waiting, but and going up the Shetland could make this would be harder up there. However, the answer is I think we have to learn how to do it in the winter. We just won't do it as fast. The question is, in the end, if we're going to put into 1,000 megawatts, which is going to be somewhere between 50 and 100 or 1,000 megawatts plus potentially, it's going to be somewhere between 50 and 100 turbines. You know, if you want to do that in a year or even 2 years, you need to be trying to get into winter installation. So you will do them faster in the summer, but you will expect to try and do them as much of the year as possible. And we saw that happen with fixed structures. You know, fundamentally, turbine installation was a summer activity. But the other day I was talking to one of the big suppliers who I think they were doing Murray East, and I asked them when they were going to start, and they said January. You know, so the technology has caught up, and they'll get there. We'll be at the start of the floating technology, so we need to think about how that will go. But the objective would be to try and do them in all year, but there's a practical basis, and it's certainly, Kincardine said, it's difficult.
Yeah, by keeping things being integrated inshore, we actually improve the number of weather windows, essentially, where we can do the heavy lifts, which are the key elements. And then we can look for windows, because we only need a much shorter weather window to deploy the machine. We can look for those, and when we see them, if we're close to site as we are, we're talking here only a few kilometers, you know, we can actually have everything ready. Weather window comes up, take it out, get it on site.
Anchored up, moored up, and then we've still got other things we have to do, connecting cables, but it's about making it safe and anchored at site. That's the first thing. Yeah. That's the first stage we have to get to.
Yeah, because that lets us get on and do other things. When a weather window comes up for cables, etc., we can start doing that.
Thank you.
What we're really trying to do, if there's anything on any schedulers on here, we're trying to parallel this, not serial construct it. Okay.
Thanks, Paul. I'm going to move on because we have so many other questions that we'll aim to get through all of them. And to the audience, if we don't get through your question, because there are loads and loads in, we'll make a huge effort to get back to you. So moving on to the next question that's directly at Paul. Regarding future employment, I believe your numbers relate directly to the offshore wind project. Have you looked at the number of jobs which would be generated as a result of local hydrogen production?
Not as yet, because we've got no expertise. All I can really do is say what the wind turbines can do. We would be looking at partnerships as well for hydrogen production, so a lot will come from that. Where do they want to be? What technologies are they going to use? There's a lot of unknowns there, so I've stayed with the wind turbine side so that I can answer that one with a degree of confidence.
I mean, I think that's key here. We are in discussions with others who understand hydrogen, and assuming that we win the site, then they would be alongside us talking about how to build the hydrogen plant, and that's a non-trivial piece of kit. It is basically the kit exists at a sort of 1 or 2 megawatt scale, and you just build a number of them. But that's that is not something within our expertise. But what we're assuming is that to maintain the schedule we want, we would need to export. We need to convert the electricity into hydrogen and then be able to export the hydrogen. And that involves talking to, obviously, Sullom Voe from the export side and to the hydrogen company for the development of the hydrogen. And we are in those discussions with various different players. But in the end, you have to win the site, and that's what we're here to try and do.
Thanks. Right, I'm going to move on to the next one. 48 hours tow to site. Can you expand on what was the learning for that?
The Tota site, on Kincardine, the Tota site was much longer.
Yeah.
What we decided on as a limit, as a lessons learned, is not to exceed 48 hours.
Yeah.
Tota site. The way Kincardine was built was very apt. It's a small trial. We had to find yards that could be built in, and that happened, and it got built. But the sea tows were very long, and when you've got a long sea tow, you've got risk. So this is where the modular idea comes in, that we bring things into a local port, we get them assembled, we put the turbine on, and we take them off as quickly as possible onto the site and lose the risk. So, I mean, we'll be looking at, if you're towing at 2 or 3 knots, within a day you would have a structure out of, for example, Dalesville and being anchored up. 2 days till it's absolutely rock solid.
Absolutely great. I think the webinars like these, it's connecting an audience who are looking to get involved, and it's also yourselves showing the opportunities that you have to offer. And before we come to the audience question, I would like to ask the panel, have you got a question that you would like to ask the audience or get some feedback from the audience? I'll come to Kirstine first. I think when we talked about it, we'd initially thought, how is the supply chain feeling about getting up to this opportunity? So Kirstine, over to you.
Yeah, I think for us, we really do want to work with existing infrastructure providers. We don't believe that we should come in and tell people how it's done. We really want to be working to help Shetland's economy thrive. So it's about hearing from existing service providers what aspects they're interested in helping us provide. And for us, the benefit of that then is a continuous supply of future jobs. So I don't know, is there anybody that would like to ask a specific question about something they're interested in that they want to get Alan and Paul's views on just now?
We've got lots of questions around about, have you secured a design company for the floating substructure? People are looking for very specific answers in their area of expertise, which is absolutely fine.
Yeah, indirect answer to that one, actually, Jaya. We haven't, because the design companies tend to be the people that have the concept. So, for example, if you want a principal power turbine or substructure, you go to principal power. We are not settled on that. So that's a quick answer to that one.
Okay, and following on with what Kirstine said, our next question, hello, to what extent would you be looking to engage with or utilise local project management companies, and what stages of the projects would they be required?
I'll take that one. So yes, we would be looking to do local project management. We talk about a wind farm as a project. It's not, it's a whole sequence of much smaller contracts. So we would look, let's start at the end of the project, the O&M base, let's say. That can be managed locally. It is perfect for many companies, building contractors, architects, etc. can do that. The installing of the cables running to the shore crossing, that is fairly standard civils works, and that can have its own project management package as well. The integration, the assembly and integration of the substructures onshore and then integration of the turbines offshore, they are project management, need project management as much as anything. And again, they're packages of work which can be delegated.
Thank you. I'm going to come to a question of a different sort now. You mentioned that your Vision Anyone is part of a wider strategy that includes your Irish and Celtic Sea projects. Do you envisage those projects also being developed without mainland grid connection in mind?
And the Irish, yeah, the short answer there is no. The Irish Sea grid projects, the Celtic Sea projects, we have grid connections for. Morecambe, we're in the process of finalising the grid connection. The Irish projects are nascent, but we have been looking at grid connections into Ireland for those. Shetland's different, and Shetland is the start of what is a huge opportunity in that I know the Orion project, we've been talking with them, the idea that we switch to hydrogen, and you know, we have looked at a grid connection to Shetland. It wouldn't be available until 2033 at the earliest. It's a long and expensive grid connection. So it really does start make you think that the world of hydrogen is here. You know, the UK will have targets for 10 gigawatts of hydrogen by 2030. So there's a huge amount of opportunity coming, and the question is how do you access it? And Shetland is just got all the infrastructure and opportunity ready for that. You have a huge terminal in Sullombo, which is ready for being repurposed, and I think the owners of that terminal are quite keen to do it. It's all about finding the offshore wind power. You know, from our point of view, is get the site, get the wind that going, find a way of developing that site, and then say, how are we going to monetize this? And that, to us, if we want to do it in this decade, it's got to be through hydrogen. And we also believe that from what we see and what we know and the discussions we're going, hydrogen has, over the last year or two, gone from being something which might come one day to something that is going to be a serious business by the end of this decade. I got involved in the wind business in 2003. We built the Beatrice turbines, the two demonstrators on jackets in 2006. And I was then involved into the first racing round Scottish territorial waters, round 3, etc. And basically, there was a feeling that the wind industry was starting to happen. I think that that's where you are now with hydrogen. Hydrogen is going to happen. It's just a question of how quick and how fast, and we want to be pioneers within that. We don't want to be the hydrogen people. We want to be the people providing the basic energy that they need in order to be able to make hydrogen real. And we've got a number of discussions with people about that.
There's a specific question on hydrogen. What do you have in place for processing hydrogen, drying, filtering, compression and storage?
My answer to that is we have a number of companies we're talking to, one in particular that we know well from Aberdeen. And when we're doing the hydrogen side of it, if we win the site, we'll be sitting here with them and I'll be saying to them, please tell us about what the facilities are that needed it. Because there are several different things. First of all, you've got to electrolyze the water. Then you've got to determine how you're actually going to transport it and how you're going to, what processing you have to do that. Are you going to sell ammonia? Are you going to sell methanol? Are you going to use what's organic transportation? I forget that there are various different opportunities. But the first one is probably not methanol. It is ammonia, because ammonia is the largest traded chemical in the world, and there are vessels and things around to do it. Liquid organic hydrogen is probably the furthest away because those vessels don't exist yet. But some of them will be there, and which way we'll go will be part of the discussions with the hydrogen company, who will be a part of this development.
Yeah, just on liquid organic hydrogen carriers, and apologies I had to dive out there, you just about heard a chorus of German shepherds having a fight, so I had to get out quick. The SVAC vessel I showed is an SOV example. SVAC are actually building these vessels now with all the tankage ready for liquid organic hydrogen carriers, which is basically hydrogen chemically dissolved into an oil. You load the oil onto the vessel into, say, 10 tanks or so, and then the oil is taken out, put through a process. The hydrogen's released, the oil's put back into the tanks, and you then run the vessel on a fuel cell, so hydrogen fuel cell for the electrics. You come back in, you discharge the oil, take the oil on board, and the oil is recharged with hydrogen. So it's a technology that's coming, and it's seen by the shipping operators as a good one, as is ammonia.
Okay, thank you. We're going to move to concrete now. To what extent is concrete becoming a viable alternative to steel as supply chain issues become a concern? Concrete seems to be used on some floating projects. Is it being considered more actively for the future?
It is being considered. We have looked at concrete for Whitecross. What we're seeing with some concrete structures now, the ones that are most obvious and local are the Highlands ones, which are concrete spars. That's what's in Highlands, Scotland off Peterhead. It's what's currently being built and installed for Highlands Tampen, which is the Norwegian energy transition piece of supplying Snora, I think, and one other with electricity.
And Snora.
Yeah. So the thing with concrete is it actually it's much heavier. In terms of the structure, is much heavier. And if you do the analysis, you find out it's got about the same amount of steel in it as a steel structure. The difference is that it's rebar, so it's easier to put together. We don't discount concrete at all, because generally a civil type contractor could build it. In theory, if you can build a bridge, you should be able to build a concrete substructure. One issue that does come, however, is the size of them. A 4,000-ton substructure like the principal power ones we showed, that would turn into something like a 24,000-ton concrete structure. Physically much more massive. What that then does is if you've got any current running, you need much bigger moorings to resist the force, bigger moorings, bigger anchors, more spread. There's a lot of consequences of concrete. I am not averse to it. For these semi-subs that we're looking at, which are relatively shallow, I think steel's probably the better material, but I wouldn't rule out concrete completely.
I think the answer is, yeah, we'll look at both, and concrete has some opportunities, but we just don't know the answer as yet. We generally tend to favor steel, but we're not ruling out concrete. We did try to look at it for Kincardine, and in the end, we found ourselves driven back to steel. There's a number of challenges with concrete, but there are a number of players who've got concrete vision of the future. So we'll see if they can actually persuade us that that is a way to go.
A member of the audience has just shared that Magnora have stated that they will use concrete structures on their West Coast site. Now, we've got just about 5 minutes left of the webinar. What I'm going to do is going to give one final question, and I'm going to come to each of our panelists to give sort of your key final messages. Final question. West of Orkney Wind has many similar objectives. Is there any collaboration with this project?
Well, we haven't looked west of Orkney. We've only looked at the projects and the sites that we're interested in. We are a developer, so no, that belongs to another developer, and they have their views and their understandings. It's like BP and Shell to some degree. They don't do it the same way.
Okay, thank you. In the final 5 minutes, I'd like to come to each of you, and what would be your key message that you would like to, or just anything you would like to leave the audience with? I'll come to Kirstine first. Kirstine.
Okay, I think that the thing that I find really exciting about flotation is that they're a catalyst of ideas. And our demonstration projects prove that we're able to take that continuity of knowledge that we gain and then apply it to fast-paced, commercially deliverable projects. But because we are catalysts, we're also really, really keen to hear from the supply chain to understand how we can work with them. And so hopefully you can take that away from today, that we're open to talk, we're keen to talk, and we really, really want to hear your ideas as much as you want to hear ours.
Thank you. Paul?
Very similar to what Kirstein's just said. We want to work together. We are not fixed on any design, any material. We're completely open to what works for the local area. Okay, that's probably the biggest thing. We adapt to the local areas. It's easy to say, let's say I was going to work in Norway, I'd probably be saying, yeah, let's go for a big concrete spar because I've got 90 meters of water to build it in. You know, Dalesville and around Shetland's pretty deep, but it's not that deep. Hence, we adapt the structure to the ports, etc., that we can build in and operate out of. We are flexible. We will listen. We don't have all the answers. In fact, generally, we don't have a lot of the answers because, well, we've done it. We've all got experience of it. It's experience of a very small number of projects. There are only 2 floating offshore wind farms in the UK.
Thanks, Paul. Alan?
Yeah, one thing just going concrete, much as that we tend to come and prefer the steel, we have a partner who's very keen on concrete. You know, as I said, we did try it on Kincardine. Kincardine taught us a lot, but this is a new game. You've got to take that experience and you've got to then apply it. And that is where there is this opportunity that we're working on, trying to see whether or not we can do a small prototype project in and around trying to decarbonize the northern North Sea, a few fields there, and then use that to learn before we start on the big development for the full-scale project, which will be, you know, 1,000 megawatts plus. So that is our idea there, and we believe that that would provide a real opportunity for the sites in Shetland, Sullomvoe, Dalesville, Lerwick, to actually get a small bit project into the water faster, which would ultimately go to the oil fields, power the oil fields for 10, possibly 15 years. But the problem is, if you just try and do that, it's not commercially attractive. But at the end of it, it would come back because it would be the same basic design as that which we're going to deliver at NE1. And therefore, it would be just another string NE1, and we'd be able to run it for another 20 years there. And that is an idea which may have a significant impact from our point of view of accelerating that development, and from the Shetland's opportunity, a chance to move it forward quickly.
Thank you. And I'll come to George. And George, maybe you can cover, because our audience are looking to connect with, you know, the speakers. They're looking for the opportunities. How can people register their interest?
Yeah, I
that
think
sort of thing. George.
yeah, so thank you for your presentations, Paul and Alan. One thing that Paul didn't mention, he's gone through the scope of the project, but he didn't mention quite so succinctly the speed that this is going to happen. If this comes to fruition, they're talking about making one of these structures every week. So that's assembly and launch of a structure. So it's an awful lot of resources needed there. And I would encourage everybody. I'm going to be sharing email addresses of the panel and a copy of the slides after this call. And I would encourage anybody that can help with that to get in touch and start speaking to each other.
Yeah, just on that one, George, I wouldn't expect to start at 1 a week.
No, yeah, that's we'll ramp up to that.
With a bit of practice, I think we can get there, but let's not expect to start at that rate. We will be much slower because everybody's got to learn. This is production line assembly we're talking about here. It's not doing what oil and gas do, where everything's a prototype. This is production line. Let's go and build 50 of these. Let's go and build 100 of these. They're all the same. Everybody learns. We start off slow, we build up speed.
Yeah.
Okay. So
Well, we've certainly started off slow and built up speed in this webinar because that's us at 12:15 now. Can I just thank our audience very much? We have captured all of your questions and we'll do our best to make those connections, give you the information that you're asking. So thank you to the audience and thank you to our panel today. And we hope to see you at another webinar soon. Bye-bye now. Bye.
Okay,
Bye.
bye.
Bye.